Welcome back, guys, to Long Island Institute of Technology's CSEC preparation course for physics, also applicable to GCSE, people who are preparing for the GCSE physics exams as well. And so we started out with section A, lesson 1, which was Galileo, simple pendulum, and measurements. Section A, mechanics, continues with lesson 2, vectors, right? We have this PDF document right here that I'll be going through and giving explanation so you guys can have some clarity of what vectors is about. If you want to access, this PDF and you haven't already, what you can do is sign up on our website, litny-ecampus.us, and self-enroll for the course, which is pretty much free. And we'll have a lot of free courses on here as well, but of course we have paid courses as well if you're interested. So you can check those out, and you would just self-enroll in the GCSE and CSEC physics exam preparation. And here you will find all our lessons and videos, links to our videos, as well as quizzes and discussion forums. If you have any questions, we can answer, or your fellow course takers, right? So let's begin. All right, so the learning objectives here is to distinguish between scalars and vectors and give example of each. You're probably wondering what we mean by vectors, and we'll get to that. So there are two types of quantities, mathematical quantities, and these are scalars and vectors. We'll be discussing addition of scalars. Oops, so sorry about that. We'll be discussing addition of scalars and using scale diagrams to find the resultant of two vectors, which is the addition of vectors, and then calculating the resultant of vectors which are parallel, antiparallel, and perpendicular. So let's distinguish between scalars and vectors. Like I said before, there are two types of mathematical quantities when describing motion or value of objects. Scalar quantities only have magnitude, while vector quantities indicate magnitude and direction. Let me clarify. So the first example we have here of a scalar quantity is distance. So the distance between two objects can be 5 meters. This only has a magnitude. It doesn't tell the direction of one object to the next. It's just the distance in between. So distance is a scalar quantity. But distance has a vector equivalent, which is a vector quantity, and that's displacement. So the example of a displacement would be object A is 5 meters south of object B. So the difference here between displacement and distance is that it has a magnitude, 5 meters, and it indicates direction of the objects relative to each other. So we can say object A is 5 meters south of object B, right? And speed is similar, where speed, we can say something is traveling 10 meters per second, right? But what direction? So the only difference between speed and velocity is this indication of direction. So speed would be a scalar quantity, but velocity is a vector quantity, in that we would instead say 10 meters per second northwards, for example. So there are a number of other examples of scalar and vector quantities. Some more examples of scalar quantities are mass, temperature, and let's take temperature. Something has a temperature, of 10 degrees Celsius. This is just an indication of magnitude. There's no indication of physical direction. So it's just temperature is just measured by magnitude. So this would be a scalar quantity, while something like acceleration, we can say 80 meters per second squared westward. So this is a vector quantity, right? So mass, temperature, work, energy, and time are all scalars, while friction, momentum, acceleration, force, or weight, because weight has a direction, for example, 50 newtons downwards, velocity and displacement, these are vectors. And again, scalars are just magnitudes, and vectors are magnitude and direction. So I hope we have that clear. And yeah, this is where I was just this is where I was distinguishing between scalars and vectors some more, where we could say scalar quantities don't indicate any direction like vectors do. Some are even the same with the exception of direction, like speed and velocity. We can say a car is traveling at 150 kilometers per hour. This is speed. But if we say the car is traveling at 150 kilometers per hour northwards, then this is velocity. Some scalar quantities don't have a vector equivalent, such as time. So speed has a vector equivalent, which is velocity, but time is a scalar quantity that does not have a vector equivalent. Let's move on to addition of scalars. And addition of scalar quantities just follow the regular normal rules of arithmetic. So if we say a tank holds 10 meters cube of water in volume, if 4 meter cube of water runs out, there will be 6 meter cube of water remaining. The rules of arithmetic allow only one calculation and only one answer. So just like regular arithmetic operations with scalar quantities, we would just subtract the amount that ran out of the tank from the initial amount, and we would get the answer. And I apologize, this should also have a cube right here. So the answer would be 6 meter cube, right? Same thing with maybe kilograms. A 5 kilogram mass added to a 12 kilogram mass is 17 kilograms. So addition of scalars is simple, is truly simple, adding and subtracting. And so they have magnitude. That's what makes it easy. But when we're discussing the addition of vector quantities, then it becomes completely different. This regular method of addition and subtraction won't cut it, because we have to account for the direction as well. And I think the best way to start is through an example, right? So follow me along as I read. So the next objective is to use scale diagrams to find the resultant of two vectors. In other words, the addition of vectors. A single vector's value and direction can be found using two other vectors at right angles. This is known as a resultant vector. So we'll use an example right here. Alicia tries to row across a river at a velocity of 2.5 meters per second. The river has a current of velocity 5 meters per second parallel to the banks of the river. Calculate the resultant velocity of the boat. So, and we'll link this back to where we said that a single vector's value and direction can be found using two other vectors at right angles, right? And this is known as the resultant vector. And we'll show a diagram down here to show what we mean. So first we will draw lines that represent the two vectors given. And here is the first vector, which is Alicia trying to row across the river at 2.5 meters per second in that direction, and the river's current is traveling in this direction at 5 meters per second, and that's a velocity, sorry. And so there are two acting forces here perpendicular to each other. So there will be an actual resultant force that actually represents Alicia's motion across the river. Because the keyword here is Alicia trying to row, but where she actually rows, the path that she actually takes will be the velocity, the resultant vector, or the resultant velocity. So secondly, we will represent these motions of velocity in a graph. And here we kind of take away the physical aspect of it, which is the river, and represent it fully mathematically. So Alicia tries to row 2.5 meters per second this direction, and the river's current is going 5 meters per second in that direction. So follow along with me here, guys. I know this can get a little bit tricky, but it's not that difficult. So like I said, we have the document, so you can go over and read as much as you need to. But I'll try to explain as best as I can. So because Alicia's rowing velocity is obstructed by the river's current, there is a resultant velocity. These two velocities at right angles can be used to find the resultant velocity. The resultant velocity is a vector, not a scalar quantity, so it has magnitude and direction measured by an angle. In order for us to find the magnitude, so first we'll find the magnitude, we will use trigonometry, but we will also find the direction using trigonometry as well, but first we'll find the magnitude. So persons taking this course might want to brush up on their trigonometry, which is quite fundamental for pre-calculus and physics and stuff like that. So the first thing we need to do in order to find the magnitude and direction of the resultant vector is to set the vertical arrow. As you can see up here, the arrow is over this side. But the first thing we need to do is set this vertical arrow so that the direction of the arrow is flowing. So it moves from here to here. So instead it will look like this. But the magnitudes remain the same. So Alicia rowing across the river at 2.5 meters per second, and the river traveling at 5 meters per second. Next, we'll use Pythagoras' theorem to find the hypotenuse. This will give the resultant vector's magnitude. So the magnitude of her movement in velocity using Pythagoras' theorem, c squared is equal to a squared plus b squared, we find that it is 5.6 meters per second. So that's the magnitude of Alicia actually going across the river, the resultant vector. But I'll actually do this calculation one step at a time so you guys can understand. So the reason why we use Pythagoras' theorem is because you notice that she starts here and ends up here, but the actual motion or the displacement is traveling that way, right? So this makes it look like a triangle. And what do we use in triangles? Trigonometry. And so we need to find this hypotenuse right here. And this is the formula that we use to find the hypotenuse. So I'll move to the sketch pad here. So c squared is equal to a squared plus b squared, right? So the first thing we will do is decide what is A and what is B. So the reverse current here would be A. So let's continue the equation. 5 squared plus B, which is 2.5 meters per second, 2.5 square. And now let's continue this. And there's a square here as well still, right? So 5 squared we know is 25, and 2.5 squared, let's use a calculator for this. It's 2.5 times 2.5, and that gives us 6.25 plus 6.25. Now let's add these both. 6.25 plus 25 plus 25, and that gives us 31.25. But this is not the answer. C squared is 31.25. What we need to find is C. So in this case, we will find the square root of 31.25, and the square root of the answer 31.25 is 5.59. So we'll round that to 5.6. And there we have 5.6 as the answer for C. So that 5.6 meters per second would be the magnitude of the velocity of the resultant vector. But vectors have magnitude and direction, so we are not quite done yet. So let's scroll down. So we have now established that the resultant vector's magnitude is 5.6 meters per second. Now to find the vector's direction by measuring its angle, we will continue with the trigonometrical approach. So we have the first two vectors that we started here at right angles and their values, and now we have the magnitude of the resultant vector, which is 5.6 meters per second. We need to find the angle, and this will indicate the actual direction that the resultant vector is, or the actual direction that Alicia will row as a result of these two forces, as a result of these two velocities, to be more specific. So here we have theta, which is representing the angle, and we will continue with trigonometry to find the value of this angle. So we know the opposite side, which is 2.5, opposite of the angle, and we know the adjacent side, which is adjacent to the angle, which is, so it's 2.5 and 5 meters per second. Let me actually draw this diagram. So let me get rid of all of this right here. Okay, that's not how we will do it. So let me make some space. Oops. All right. So let's draw this triangle right here. It's not the best, but bear with me. So 5.6, 2.5, and 5. So we need to find theta, which is this angle. So when using trigonometry, we use the values of the sides, the lengths of the sides that we have available of the triangle. Here we have all the sides, so we can really use pretty much any one of the sides we need. However, it's best practice not to use this side, the hypotenuse, because it's the side that we found. So we will use the sides that were given, which is the opposite side and the adjacent side. So in trigonometry, when we have the opposite side and the adjacent side, so we'll have our little mnemonic here. So ka toa. And if you don't know what this means, it means if we have the opposite side and the hypotenuse, we use sine. If we have the adjacent side and the hypotenuse, we use cosine. And if we have the opposite side and the adjacent side, we use tangent. And so we're using the opposite and the adjacent, so we'll go with tangent. So the tangent of the angle is equal to the opposite side over the adjacent side. So the tan of the angle is equal to 2.5 over 5, right? But we don't need the tangent of the angle, we need the actual value of the angle. So we will have the angle of the actual value of the angle, right? So would need the angle is equal to tan, that's inverted, 2.5 over 5. So let's move over to our calculator here. So we will go tan inverted 2.5 over 5, and here we'll have 26.56. We'll go with 26.6. So the angle is equal to 26.6 degrees. I hope this isn't too messy. And so here we have right here 26.6 degrees. So in conclusion, the resultant velocity of the boat is 5.6 meters per second, traveling at an angle of 26.6 degrees to the banks. So here we have the magnitude of the resultant velocity and the direction in terms of the angle in respect to the banks itself. So it's pretty cool how we can use mathematics to solve a real life problem or situation or natural things in nature, right? And that's what physics is about. So let's continue, and next we'll discuss parallel vectors. So and antiparallel vectors. So we already did perpendicular vectors. So antiparallel and parallel vectors. So if two collinear vectors A and B act in the same direction, then the angle between them is 0. So we'll take two collinear vectors here, and they're acting in the same direction. The angle between them is 0 degrees. If a vector A has a magnitude of force 5 newtons, so this is A here, 5 newtons, is combined with a parallel vector B of magnitude 10 newtons here, the resultant force is 50 newtons. So with parallel vectors, the resultant force is added between the two vectors, but the angle is zero, because as you can see here, they're not at any angle to each other. But with anti-parallel vectors now, that means they are traveling at directions away from each other. So if we have vector A traveling in this direction and vector B traveling in this direction, and this is 10 newtons and this is 5 newtons, when you add these vectors, it's almost like adding a negative number. So if we have 10 plus negative 5, it's basically 10 minus 5. So if we have 10 newtons here going in that direction plus 5 newtons going in the opposite direction, it's actually 10 minus 5. And so the resultant force would instead be 5 newtons instead of 50 newtons when dealing with anti-parallel vectors. And the angle would be 180 degrees, which is the angle of a straight line. And that's it. That's basically it for vectors. It takes a little bit of practice, but it's one of the shorter lessons, so I hope this video helped you guys. And like I said, you can enroll on our course on Long Island Institute of Technology and get access to all these free lessons, as well as link to videos, quizzes, so you can be prepared. So thank you for watching, and I think the next lesson will be about statics, as you can see right here.